In the previous chapter of this, we left off this thing. So basically we figured out how we can loop this simulation, created the camera, and then what we left to do is we need to create a lights and render this thing out. And what I found out was that I didn't really want to create another Redshift tutorial. So in the initial I said that we're gonna build all the shaders and stuff in the Redshift, but I already covered the Redshift rendering part in this tutorial, so I thought I better off create a Karma one. So in this tutorial, of course, we're gonna continue this tutorial, but we're gonna build everything in the... So this is what we left off with in the previous tutorial. As you can see, everything is looping and everything is good. Let's create a loop network here. I'm gonna call this render, and I'm gonna take the last node from our setup, so Ctrl C, let's drag it back, and then let's create sub import, and let's Ctrl V, so copy this path in, and I'm gonna select here a relative path. I just like to work with the relative path instead of the absolute. So by default, if you go to your scene graph tree, so if you don't have this option, you can switch either to Solaris here, or you can create here split pane top bottom, and you will get basically second viewport here, and you can press this plus icon here and then create Solaris. So you need scene graph details and then scene graph tree. So this is two like tabs you're gonna be working while using a Solaris. So this is quite important here, and also this is also useful. I'm gonna tell you why in the little bit later. And by default, of course, you are in the Vulkan viewport here. So if you press this perspective button here, you can switch this to Karma XPU. And also I'm gonna change the path, so I don't want this to be called a sub import. So this is our like a blocks, for example. And then because we have a path attribute in here, not path, but there are the name attribute, it's gonna import all of those pieces individually. This can be used for some cases, but in our case it doesn't really matter. And let's also rename this import. Let's also import the camera, so scene import camera, and then it's gonna import all of those cameras. And also, as you can see, it saves our path here, so transform camera as we had in our object network. So you can go to this camera, and then you can even do a flipbook, which is also quite useful. So if you don't want to render this to disk, you can select in this flipbook. This is quite nice feature that I found. You can limit frame time. For example, each frame gonna be rendering only for 2 seconds, and then just select this current beauty path, and then you can do flipbook of your camera viewport, which is quite cool. But of course, I'm not gonna do this. It's just a tip that I wanted to tell you. Okay, so this is import cameras, and let's create a basic HDRI here, so dome light, and then let's call this HDR. So the dome light that I'm gonna use are in my hip textures, and this is the dome light that I want to use, and I want to of course rotate this a little bit on, so Y, and then I want to rotate this like this. And in the so that's pretty much it for the HDRI. But what I wanted to do, I want to add a background. So you can do this either in your composition, like comping app, so for example After Effects or Nuke, but I just like to have this white background in my render directly because I don't really do much compositing in these simple like motion design shots. So if you know, you can press this D button on your viewport, and then you can use this display environment lights, but this is just for the viewport, so it's not gonna be exported to your render file anyway. So I just always turn this off and then just save as default. But how you can add, you can create another dome light, and this is not gonna override your old dome light, but it's just gonna create another one on top of that. So you can call this, for example, BG for background. And then the cool thing is you can go to this Karma tab here, and then you can set or create here. So just override this parameter and then turn on render light geometry. And now you're gonna get this in your viewport, as you can see. But of course, we don't want this to affect our shaders or scene overall. So you're just gonna go here, diffuse multiplier 0, specular multiplier 0. So now we are saving our HDRI, but we just still get this nice white viewport here. And also I'm gonna just lower down the color just a little. So this is the basic. Let's also create a material library. This is going to be used for materials. So let's dive inside and create default Karma material builder, and let's call this blocks material. And then if you go in your graph tree, you can already see that we have our material in our scene graph path. But to assign this material, first of all, you want to fill in this material here. So you can just press autofill material, and then you can press assign to geometry. And your path here, basically you can just drag and drop this block to here, and it's going to assign your material to all of those pieces. For example, even if you want to have only to piece 1, you can just put this to piece 1, and as you can see here, this is actually, this piece only have materials. But of course we don't want to do that, so we're gonna just use blocks, and that's it. So this is our like a basic setup for this scene. Let's actually create a lights. So we're gonna do that. Let's create a light node, and then if you go out of your camera, here is your light. In this case, this is just a point light. As you can see, we're gonna switch this to rectangle light. This is basically your area light in any other software, and you can just push it outwards just a little bit. And then we might want to disable for now all of the other lights. So if you press Q, you can disable them, and let's increase the intensity. You can see this is our, for example, this is key light. The cool thing with Solaris that I like a lot is this constraints tab here, and you can switch this to enable look at. And what's gonna happen is that you can just take this part here and you can just rotate this around. Basically, this is a really nice feature which allows you to do that. And then let's go to the point where this a little bit of morphing happens. So for example, frame 50, yeah, I think that's fine. And then let's take this light and let's position it. So we're gonna position that something like this. So this is the key light here. And as you can see, it doesn't really change the rotations because it's based on the constraints. So you can just say something like this. We just rotate this a little bit, maybe even more like this. Okay, that's fine. And then what I want to have, I want to change the width and height of the slide. So let's just increase this a little bit and maybe decrease the height a little bit, something like this maybe. And if you go to the Karma tab here, you can basically you can change the spread of your light. So you can make it more focused in here or less, like feather out this a little bit. So I'm gonna put this to like something like this. And also a cool thing is you can twist your light based on these constraints. So you can just twist this a little bit and you can make light, for example, this, which in this case I like. And also I want to increase the width of your light as well. So just increase this a little bit, something like this maybe. Let's turn other lights on and see what we have. So we have something like this. Of course, our light is too strong, so let's decrease this to 5, for example. And also what I want to do is I want to decrease this dome light a little bit. So let's make this 0.25, maybe just a little bit. And what I don't like is I don't like that this light has some color, and as you can see here we got this colored reflections here. This can be changed. You can change this by using a light shader. If you create a light filter library here, let's dive inside, and you can create this filter called gel, and this filter allows you to control your exposure, saturation, gamma of your light. So this is basically color correcting your HDR. So we need to first of all autofill this, so it fills our material here, and then we need to assign this. So our lights are located in the lights HDRI, so let's just take this and drag and drop it here. And if you start off by changing the saturation, let's add saturation, add it. And as you can see, it becomes a lot more saturated, but we want to do the opposite. So we just want to desaturate it. So let's put this to 0. And as you can see, we just essentially desaturated our HDR. Other thing we need to do is we need to have some nice rim light here. Let's lower down this HDR a little bit more. And let's take another light. Let's also switch this to a rectangular, and let's put it back a little bit here. This doesn't need to be constraints, but you can still do that. You can just still make it look at constraints. Let's increase the height and then the width as well, and let's increase the intensity. And as you can see, we get this really nice rim light here, but of course I don't want this to be that intense, so let's put it to 2 or even maybe maybe 2 is fine. And then let's use some color, some nice, maybe we want to do some greenish sign here. I think it looks all right for now. So we're gonna make this something like this, and then let's call this rim light. So we kind of set up our lights for now. So let's say I'm happy with this lightning lights, but the problem here now is that our camera is moving up and down, but our lights are staying in the same position. So if you just go back, as you can see, so the first frame and the last frame should be the same, but they are not, because as I said, we are changing our lights or geometry and then the camera position, but we are not changing our light position. In case of HDRI, it doesn't really matter, but in case of our lights, it does matter because they are focused in the one point, but the camera is still changing its position. So we need to fix this. And basically what we need to do, if you go back to our blocks here, you need to, this blend in transform, you need to take this and apply to the lights. So the easiest way is of course to take this parameter here, right? So let's take this. So this is, as you can see, from 4 to 2 on the last frame. So we just copy parameter here and we need to apply this to those lights. So let's create a transform node and then let's go to our frame 50. So this is our like a reference frame, right? Let's assign this transform, and by default what this transform does, it actually changes the last input primitive here, as you can see. So this is the last node is the light, so it's changing the last light here. But we want to be, of course, changing all of the lights position. So we're gonna take this and shake it a little bit, and then we're gonna use merge node to merge it back to our main stream of nodes here. And this is basically is going to be compensate for moving geometry. So basically compensate for moving geometry and then the camera. So you just take this, so we copied this parameter, and in here we're just gonna say past relative reference, and by default, of course, our light goes up, and also it's affecting only the rim light. So but we want to affect all the lights. So let's take this lights group here, let's put it here, and then we want to change all the lights. And other thing that we want to do is we want to reverse this values here. So we know that this value, so we're gonna fit this value. We know that this value starts from 4 and ends up with 2, but we want to reverse that, so it starts with 2 and ends up with 4. So we just basically we're reversing this, and also we want to so we right now we applied offset, and because of that our lights moved up, as you can see. We want to move them back. So we're gonna use another transform. We wanna say same thing, lights, and then apply to all the lights, and then shift lights. So let's call this shift lights, and then just -2 here. And as you can see, our lights back at their position. And then if you go to frame 1, it has this position, and then the frame, the last frame, it has the same position, and now lights are also looping. So if I go back to our reference frame, turn this transform nodes off, we get the same thing, right? But if I go to frame 1, I have correct light setup, but if I go to last frame, I don't have the same setup because our camera and geometry moved a little bit. So basically with these nodes, we just compensated for this, and we get this nice lights here. So yeah, all the lights that you do it on your reference frame, and then everything else should work by default. So right now we have created the lights, basic materials, and then everything is ready for the shader. So for this block shader, I'm gonna use a concrete material here. So here is my texture. So I'm gonna start off by importing it to my shader network here. Let's create a image network, and then the first one is of course color, and then it's diffuse. So I'm gonna take my diffuse texture. Let's call this diffuse, and let's pipe this into the base color. Let's go out of the camera and let's zoom in. And as you can see, I'm not sure if you can see, but I'm certainly can. There's something going on in here. What we're gonna do is we're gonna use a color correction, and I'm gonna adjust the gamma just a little bit. So let's adjust it something like this, and now it's a lot more obvious that we have some texture here. And also you can use a texture coordinates node here, pipe this in texture coordinate, and you can use a multiply node. And this multiply node basically becomes your transform, or you can use transform 2D node as well. So you can pipe this in here, and then you can change the scale. So we're gonna just maybe change it a little bit more bigger, and then maybe it's fine right now. Also a cool trick that I can show you is you can create this surface unlit node here, and if you pipe this to the surface, you can directly pipe any textures to the emission color, and that way you get basically visualization of your texture as it is without any shaders. So this thing I'm going to use a lot. I think it's fine for now. Maybe I just want to change this a little bit. Let's connect this color correct. And I think it's a little bit stretched in one axis. So let me figure this out. Maybe I want to have something like this. Yeah, I think something like this is fine. Let's duplicate this image and let's pipe in the glossiness. So this is the gloss. And by default, glossiness should be inverted to become a roughness here. And also this is not a color, this is a float texture, and then the color space is also raw. So right now I'm using ACES color space, so that's why I'm gonna select this color space as well. And let's pipe this into the specular roughness, and let's see what we get. And as you can see, you're already getting some variations in your diffuse, in your specular as well. Then the last thing is, of course, to import our height map. So the height map, it's actually normal map, so let's call this a normal map. And then the normal map is not color, but it's rather a vector 3 node here. So that way, if you select a color here, it's gonna apply the color space here, but if you select vector 3, it's directly going to import the values as it is, so basically raw values, and this is exactly what we need for the normal map. And now let's create a normal map node, and this is normal in, and then it goes to geometry normal, and we're gonna see some shader variations right now. So yeah, as you can see, we're getting this nice normal map. I'm gonna lower this down a little bit, 0.1 is fine. Let's go back to the camera, and as you can see, you are already getting some variations, but the light is too strong for me, so I'm gonna just lower this a little bit more. Something like this is fine. And also maybe this shift lights, we're gonna shift this a little bit more, so maybe something like this. I think something like this is just fine for me. And yeah, I'm not gonna do anything else on this shader. I think it's fine for now. And then we're gonna create a thing called a mix, so material X mix, and then we're gonna mix shaders here. So let's create another material, and this material, let's actually make it colorful, so maybe blue here, and let's try to mix it. So I'm gonna mix these two shaders, and at this moment it's just linear mix, but let me just pin this right now. Alright, so anytime you import the shaders in your Solaris material builder, it's gonna always recalculate your shader network, which is not really, how do I say it, ideal, because it thinks a lot every time you change something here. But I guess that's the way how USD works, unfortunately. So if you remember back in our blocks setup here, we have this mask which is used to transform between this concrete and then this balls. So we're going to use that mask in our shader, and you can check if you have any attributes or not in your graph tree. So let's select our blocks, and if you go to the graph details here, you can basically let me see. So we are not seeing anything. If I select this piece, I think you need to select this mesh type here. As you can see, you have this prim variables. Basically, this is your attributes that you have on your geometry. And in our attributes, as you can see, we have this mask attribute, which is exactly what we need. We need to import this to our shader to use as a transition mask here. So we're going to use this prim var reader node here. Let's call this import mask, for example. And let's import our mask. And by default, it's gonna work. So if you just pipe this in, we need to just invert this. So let's invert this. And yeah, as you can see already, we are getting something. We just need to work on this balloon shaders just a little bit. So what I'm gonna do is I'm gonna up the roughness, and also I have this fabric normal shader, normal texture here, and I'm gonna use this texture. So let's create another image node and let's import this in. So let's fabric normal, and then of course this is vector 3, and let's just copy this normal map here and let's just pipe this into the normal. As you can see, we are getting something here, but because we have different set of UVs. So in this case, this texture doesn't really like fit the sphere one. So it fits the concrete right, but the spheres are not right here. And the thing is that we need to import our second UV map that we have. So we have UV and UV2. We need to import the second UV map. And by default, from what I know, Solaris doesn't really import this. So it renames the UV map to ST, and we have UV2. And I think you can, somewhere here, you can select this to import it as a ST2. But in our case, it doesn't really matter because we can use for example, you have a texture coordinates, right? And you have this index 1, 2, 3, but you can use a Primvor reader here. Select this vector 3 and then just import this as a UV2 and then pipe this into texture coordinate. And as you can see, now it's gonna work correctly because we're using, if you remember first tutorial, we set up this for like ball geometry, and this is now working correctly as we planned this. You can increase this a little bit so we have this nice balloons here. So this is our second UV map. Let's use a little bit of subsurface. So let's increase it a little bit and maybe increase down the scale. And a cool thing as well is you can use a random color node here, or you can rather use a random float. And the cool thing in here is you can another Primvor reader, and in this case select the integer, and you can import your class attribute that we have here. So for each of those balls we have different class, so unique index attribute, and you can use this as a seed. And then this is UV2, and this seed can be remapped to a colors. So if you select this, for example, magma, and then pipe this to the base color, and as you can see, you get these different nice different colors. And then you can also connect this to the subsurface color to have the same subsurface. And what I like to do in the subsurf, I like to color correct this and up gamma a little bit, and then let's lower down the saturation a little bit. But of course those colors are ugly, so let's change it a little bit. So the base color, let me make it white. I'm gonna switch this to a constant. That way I can select individual colors so nothing in between will happen. So in this case I'm gonna select some nice green, and then also maybe cyanish, something like this. Yeah, something like this is fine, I guess. Maybe more white. And you can change this seed by adding something to this value. So if you add something, it's gonna change the seed. I'm not gonna do that in this case. So something like this, I think it's fine. Let me turn off the lights visualization and let's bring this down. We don't really need that. And yeah, so that's kind of pretty much it. So all we need to do is to create a karma render node here. Let's select it, and by default it's not gonna recognize our camera, so we need to just press this button and then select this camera, and then the resolution is square. So this is from aspect ratio from our camera, but we can change this, of course. So if you go back to our camera, you can change this, for example, to Instagram scenario, and let's increase the focal length a little bit more, something like that. And let's check if it's working, the loop is working or not. So the last frame is the same as this one, and then the first frame is also. So yeah, that's good, that's okay. Let's change this resolution here as well, 1080 to 920, and then let's switch this to XPU. So let's render this to render. Let's call this morphing blocks. Okay, let's render in EXR, and then we can composite this in Copernicus. So I want to set this path trace sample to 512, and then you can also enable motion blur if you want. And the motion blur is either gonna work based off of a velocity attribute, or you need to use a cache node. So you need to cache your whole USD, and let's select this to subframe sampling, and right now you can enable acceleration blur here. Okay, so it's in camera here, so you can already see this happening. But if you want more motion blur, you can change this camera. So if you go edit, camera edit, and pipe this in here, and then the camera you want to edit is this one, so put it here, and then you can edit your camera preferences. So for example, let's change the shutter open, and if you increase this, so let me just say copy, paste, and this one should be minus. You can increase this right now, and you're gonna see a lot more motion. Okay, I think this, if you use this cache node, you need to enable this use camera prim, and then the camera prim is actually this one. So again, drop this in here, and right now it should work. Yeah, so we get a lot of motion blur here, which we of course don't want. So let's just lower down this a little bit. And of course this cache node will recache each time you change something up here, which is not really convenient. So you may want to disable this if you're not doing any motion blur and stuff. And also depth of field, of course, is also can be changed in here. So if you set this f-stop here, 0 means no motion blur or no depth of field, and if you start to change this, you already see that something is blurring right there. So let me set this to 75.75, and then if you select this camera edit node and then select this handle here, you can press shift F and you are in the focus select mode. And if you press shift and then left mouse button, you can select where you can focus this motion. I think you can. Why it's not really working? For some reason it's not working, but it's actually, oh yeah, there you go. Nah. So right now it's working. I don't know, but you can basically select, if you press this shift, and then you can select to this one or to this monolith here. So I'm gonna select somewhere around here. So this is my plan. So that's pretty much it. Let's change this to 1.8, for example. I don't want a lot of motion blur, just a little bit. And I'm not gonna do any motion blur. But if you want, as I said, you can just select this cache node and use motion blur, but I don't need. And then, yeah, I think this scene is done. We can select this specific frame range here, and then select monitor, employee monitor, and press render button. So the rendering is done, and as you can see, this is what I get. This is basically a raw AXR file, and then this is basically in the ACES color correction. That's why we're getting this kind of washed out incorrect colors, but we're gonna fix that in a moment. But as you can see, everything is looping, everything is fine. So let's create a copnet just to composite this just quickly. Let's create a file. I've already shown you some of the techniques that I use in here in a previous, but if you select your render file and then hit space 3, you can go to the front view, and then you can start to composite. So for example, we get a little bit of motion blur here, HB A to HB, and you can use a denoise AI node just to denoise this a little bit. But as I show you in tutorials, I like to just blend this a little bit, so blend in back a little bit of noise. And then also we can adjust brightness a little bit if you want. So maybe something like this, maybe a little bit of gamma as well, 1. So this is your default gamma, and you can start to adjust this. And because we're working in ACES mode, as you can see, as always, you get a lot of nice dynamic range, and you can really dial in your colors. You can also use something like glow, but in this case, I don't think it's necessary. So you can just leave this as it is. And then if you use raw file image output, you can, for example, select this last node. I usually create a null, and I say out comp, for example, and then drag in here. And you need to convert this from ACES to sRGB because we are going to save images. So let's render, and then we're gonna say underscore PNG slash, and then let's call this morphing blocks. and then $F3, and then of course it's not EXR, it's PNG. And in here we need to bake this open space, and then choose sRGB, and then choose your view config. In my case, I'm using a Redshift OCO profile, but if you are using, for example, the default default open color IO, you should get something like ASYS CG or something like this, so you're gonna need to choose that. But you can still download the Redshift config. I think it's much easier config to work with, even with Karma, because it doesn't have a lot of unnecessary profiles that you don't really use in CG. So that's why I usually stick to the Redshifts. But this still is gonna work with default OCR as well. And then select the render frame rate, and you can hit render to disk. So here is the sequence. It's rendered, and then if you open this up, let me open this in the GV player, and as you can see, the colors looked correct as we had in our Houdini. And then of course the animation is, everything is working fine. And yeah, that's pretty much it. Thank you guys for watching. The scene files for this scene and everything that I do on my channel can be found on my Boosty page. Check the link in the description.